Betelgeuse dimmed. One of the brightest stars in the night sky lost more than 2/3 of its normal brightness in late 2019, and for a few months, astronomers genuinely wondered if we were about to watch it explode. And the reason it dimmed has nothing to do with it dying. Betelgeuse is a red supergiant sitting in the constellation Orion, about 724 light-years away. It's massive enough that if you dropped it where our Sun is, its outer surface would extend past Jupiter's orbit. In late 2019, it started fading, fast. By February 2020, it had lost more than 60% of its brightness, enough that people who knew what to look for could see the difference with the naked eye. Turns out, the star ejected a massive bubble of hot plasma from its surface. That plasma traveled outward at about 200,000 miles per hour, cooled down millions of miles away from the star, and condensed into a dust cloud that blocked our view of a huge chunk of the southern hemisphere. To put that in perspective, the star essentially sneezed hard enough to create a dust cloud the size of Jupiter's orbit. The cloud blocked about a quarter of the star's visible surface. And this wasn't some slow fade over centuries. This happened on a timescale of weeks. By April 2020, the dust had dispersed and Betelgeuse was back to normal brightness, and we all went back to waiting for it to eventually explode. The news cycle moves fast, and space doesn't care. This got maybe 2 weeks of coverage before everyone moved on. Farfarout confirmed. The most distant object in our solar system wasn't even confirmed until February 2021, and it's so far out that it takes about 1,000 years to complete one orbit around the Sun. What's wild is that we almost missed it entirely. Farfarout, officially designated 2018 AG37, sits at an average distance of 132 astronomical units from the Sun. 1 astronomical unit is the distance from Earth to the Sun, roughly 93 million miles. Pluto, for comparison, orbits at about 39 astronomical units. Farfarout is more than 3 times farther out than Pluto. At its farthest point, it reaches 175 astronomical units from the Sun. At its closest, it dips inside Neptune's orbit to around 27 astronomical units, which means it crosses paths with Neptune regularly. Scientists think that's how it ended up out there in the first place. Neptune likely gave it a gravitational kick at some point in the distant past and flung it into the outer solar system. The object is estimated to be about 250 miles across, just barely large enough to qualify as a dwarf planet. Because it moves so slowly across the sky due to that 1,000-year orbit, astronomers needed several years of follow-up observations just to confirm its trajectory. We named it Farfarout. Not kidding. That's the official designation scientists went with. The previous record holder was called Farout, so they just added another far. Europa venting. Jupiter's moon Europa has been quietly shooting water vapor into space, and we've got multiple observations confirming it now, which means there's an ocean down there that's actively connected to the surface. And what makes this even more important is what's probably living in that ocean. Europa is covered in a thick shell of ice, but beneath that ice sits a global ocean that might contain twice as much liquid water as all of Earth's oceans combined. Hubble spotted water vapor plumes erupting from Europa's southern hemisphere back in 2012, and then again in 2014 and 2016. The plumes shoot up over 100 miles high, which is more than 20 times the height of Mount Everest. Here's what's happening. Europa's orbit around Jupiter creates tidal forces that flex the moon's icy crust. When Europa is farthest from Jupiter, cracks in the ice widen, and water from the subsurface ocean vents into space. When it's closer to Jupiter, the cracks seal up and the plumes stop. The plumes stretch over 240 kilometers into space. To put that in terms you can feel, that's roughly the distance from New York to Philadelphia, pointing straight up. And it's ocean water. Scientists think the ocean is in contact with a rocky seafloor, which means it's got the chemistry needed for life. Heat from tidal flexing, liquid water, chemical energy, everything you'd need. We've been searching for water on Mars for decades. Turns out, Jupiter's moon has been spraying it into space the whole time. Magnetar flared. In April 2020, A magnetar in another galaxy released more energy in 1/10 of a second than our sun will produce in 100,000 years. And if it had happened in our galaxy at the wrong distance, it could have disrupted satellites and knocked out power grids. And this is where the numbers stop making any kind of intuitive sense. A magnetar is a type of neutron star with a magnetic field roughly a quadrillion times stronger than Earth's. It's the most powerful magnetic field known to exist anywhere in the universe. This particular magnetar, designated SGR 1935 plus 254, is located in a galaxy about 14 million light-years away. On April 15, 2020, it released a massive burst of energy in the form of gamma rays and X-rays. The burst lasted 1/10 of a second. In that 1/10 of a second, it released more energy than the sun emits in 100,000 years. To give you a sense of scale, if this magnetar were sitting in our solar system, at a distance where it wouldn't immediately vaporize Earth, the magnetic field would still be strong enough to erase every hard drive and credit card on the planet from thousands of miles away. The burst was detected by multiple satellites, including NASA's Fermi Gamma Ray Space Telescope and ESA's Integral Observatory. Scientists think the outburst was caused by a starquake, where the neutron star's crust suddenly shifts and releases energy through the magnetic field. It lasted a 1/10 of a second. In that 1/10 of a second, it outshone the entire galaxy it was sitting in. Oumuamua accelerated. The first confirmed interstellar object ever detected passing through our solar system sped up on its way out in a way that still doesn't have a fully satisfying explanation, and scientists are still debating what caused it. And the acceleration wasn't caused by gravity. Oumuamua, which means scout or messenger in Hawaiian, was discovered in October 2017 by the Pan-STARRS telescope in Hawaii. It was moving fast, about 87,000 miles per hour, and its trajectory showed it didn't originate from our solar system. It came from interstellar space, whipped around the sun, and headed back out. What made it weird was that as it was leaving, it sped up slightly in a way that couldn't be explained by the sun's gravity alone. Objects don't just speed up in space without a reason. Comets can do this because they vent gas as they heat up, and that outgassing acts like a tiny rocket engine. But Oumuamua didn't look like a comet. It had no visible tail, no coma, and its brightness suggested it was tumbling end over end, which is unusual. The leading theory now is that it was outgassing, just very faintly, maybe venting hydrogen that we couldn't detect. Another theory suggested it might be a chunk of solid hydrogen ice, which would explain the acceleration and the lack of a visible tail. Some researchers floated the idea that it could be an alien probe or solar sail, which got a lot of press, but that's the least likely explanation. It was moving fast enough that nothing we've ever built could have caught up to it. By the time we confirmed what it was already leaving. The leading theory is outgassing, which is a fancy way of saying we think it was basically a comet. The problem is, it didn't look like a comet. Sagittarius consumed. A dwarf galaxy called Sagittarius is currently being torn apart and eaten by the Milky Way. And some of the stars you see in the night sky right now isn't from our galaxy at all. What's unsettling is that this has happened before, and it's going to happen again. The Sagittarius dwarf spheroidal galaxy is a small galaxy that's been orbiting the Milky Way for billions of years. Over time, our galaxy's gravity has been pulling it apart. The stars from Sagittarius now form a massive stream that wraps around the Milky Way multiple times, like a ribbon. The stream stretches for over 1 million light-years. Some of those stars are now mixed in with our own, and unless you're specifically looking for them with detailed spectroscopy, you wouldn't know they would. Came from somewhere else. This isn't a rare event. The Milky Way has consumed dozens of smaller galaxies over its lifetime. The Sagittarius stream is just the most recent and visible example. In a few billion years, Sagittarius will be completely absorbed, and there won't be anything left of it except its stars scattered throughout our galaxy. To put that in perspective, the process of galactic cannibalism happens slowly, over hundreds of millions of years, but it's constantly happening. Right now, as you're reading this, the Milky Way is actively eating another galaxy. We're literally eating another galaxy right now, slowly, over millions of years. Galactic cannibalism is just normal. By the way, if you're finding this kind of content interesting, I post videos like this regularly. I'd appreciate if you subscribed. Thanks. Radio burst. In April 2020, astronomers traced a repeating fast radio burst to a magnetar in our own galaxy, which was the first time we'd ever pinpointed the source of one of these mysterious signals. And it happened in our own galaxy, which means we got lucky. Fast radio bursts are extremely brief pulses of radio waves, usually lasting just milliseconds, that release as much energy as the sun produces in days or weeks. They were first discovered in 2007, and for over a decade, nobody knew what caused them. Theories ranged from colliding neutron stars to alien signals. Most FRBs come from billions of light years away, which makes them nearly impossible to study in detail. But on April 28, 2020, multiple telescopes detected a powerful radio burst from a magnetar called SGR 1935 plus 2154, located about 30,000 light years away in our own galaxy. The burst lasted milliseconds, but released as much energy as the sun produces in a full day. Here's what's actually happening. The magnetar's intense magnetic field occasionally causes the crust to crack, releasing energy in the form of X-rays and radio waves. When that energy escapes, it creates a fast radio burst. The discovery didn't solve all the mysteries around FRBs. Some are repeating, some aren't. Some come from magnetars, but others might have different sources. But it confirmed that at least some fast radio bursts are caused by magnetars, which ruled out a lot of the more exotic theories. We've been detecting these for years, and the best theory we had was aliens. Turns out it was just a dead star screaming into the void. Neptune revealed. The James Webb Space Telescope captured the clearest images of Neptune's rings in over 30 years in September 2022, revealing details that Voyager 2 barely caught and showing just how faint and fragile they actually are. And the images revealed something nobody expected to see. Neptune is the 8th planet from the Sun, sitting about 30 times farther out than Earth. It's an ice giant, roughly 4 times the diameter of Earth, with winds that reach up to 1,200 miles per hour, the fastest in the solar system. It has rings, but they're incredibly faint. Voyager 2 flew by Neptune in 1989 and captured the first decent images of the rings, but even those were hard to make out. The rings are made of ice particles mixed with dust, and they're so dark and thin that ground-based telescopes can't see them at all. In September 2022, Webb used its near-infrared camera to capture new images, and the detail was immediately obvious. The images showed not just the main rings, but also fainter dust bands that hadn't been visible before. Scientists think the rings are relatively young and unstable. They might not last more than a few 100 million years, which is nothing on cosmic timescales. Some of the ring material is probably being pulled into Neptune's atmosphere, and some might be getting ejected by small moons embedded in the rings. The rings are so faint that Voyager 2 barely caught them, and most people don't even know Neptune has rings. Neptune is 30 times farther from the Sun than Earth. We sent a probe there once in the 80s and just now got good photos of the rings. Quasar found. Astronomers discovered the most distant quasar ever found in January 2021, powered by a supermassive black hole that existed just 670 million years after the Big Bang. And by every model we had for how black holes grow, it shouldn't exist. The quasar is designated J0313-1806, and it sits about 13 billion light years away. The light we're seeing from it left when the universe was only 670 million years old, which is less than 5% of its current age. Quasars are the brightest objects in the universe. They're powered by supermassive black holes at the centers of galaxies, where matter falling into the black hole heats up and emits enormous amounts of light. This particular quasar is powered by a black hole with a mass about 1.6 billion times that of our Sun. Here's the problem. Black holes grow by consuming matter, and that takes time. The early universe didn't have a lot of time. The Big Bang happened 13.8 billion years ago. This black hole existed 670 million years later. In cosmic terms, that's almost no time. For a black hole to reach 1.6 billion solar masses that quickly, it would have had to grow continuously at the maximum possible rate, swallowing matter non-stop with perfect efficiency, which doesn't match what we know about how black holes actually behave. The light we're seeing left before the first galaxies had even fully formed. This thing existed at the cosmic dawn, when the universe was still mostly hydrogen and helium, and stars were just beginning to light up for the first time. It's forcing astronomers to rethink how supermassive black holes form. Maybe they didn't start small. Maybe the first black holes formed much larger than we thought, skipping the usual growth process. Or maybe the early universe was stranger than our models predict, with conditions that allowed black holes to grow faster than we thought possible. We've been building models for how the early universe worked for decades. This quasar broke most of them in one observation. Megacomet discovered. The largest comet ever observed was found hiding in archival data in June 2021, and it's about 10 times wider than most comets we've ever seen. What's wild is that the data showing it had been sitting there since 2010. Comet Bernardinelli-Bernstein, officially designated C/2014 UN-271, is estimated to be about 100 kilometers across. Most comets are around 1 kilometer. The comet was discovered by graduate student Pedro Bernardinelli and cosmologist Gary Bernstein while searching through data from the Dark Energy Survey. They'd been looking for objects beyond Neptune's orbit when they noticed something much farther out than expected. The comet was first detected in images from October 2014, when it was sitting about 29 astronomical units from the Sun, roughly the distance of Neptune. That's the farthest distance a comet has ever been discovered. It's been moving inward ever since. The comet is an icy relic from the Oort cloud, a shell of debris surrounding our solar system trillions of miles out. It was likely flung out there billions of years ago, when the giant planets were still migrating and settling into their current orbits. To put that in perspective, the comet takes millions of years to complete one orbit around the Sun. It will reach its closest point to the Sun in 2031, when it'll be just outside Saturn's orbit at about 11 astronomical units. Even at that distance, you'll need a large amateur telescope to see it. It won't enter the inner solar system, and it won't be visible to the naked eye. But astronomers will get to watch it for a full decade as it approaches, which is rare for comets from the Oort cloud. Most of them pass through quickly and disappear. This one we caught early enough to study the whole trip. Scientists have already confirmed it's growing a coma and tail as it gets closer to the Sun, which means it's actively vaporizing ice. We found the largest comet in history, and it had been in the data for 7 years before anyone noticed. If this sparked your curiosity about what's out there, consider subscribing so you don't miss future space content. Thanks for watching.